Hi, my name's Derry.
And I'm Evan.
And we're the researchers behind Max. We're here today to tell you a little bit more about what we produced and the future directions for Max. Evan, pretend I'm like a newbie. Can you explain Max to me, exactly what it does, how people can use it? Just give me the overview.
Yeah, so Max is a router. So what it does is it takes in your prompt, for example, and decides which model it believes will be the best in answering that prompt, right? And so depending on the prompt, it'll choose a different model. It can also take into account things like latency. So we can say, hey, this model is really good, but it's going to take 10 minutes to answer your question. This model's almost as good, maybe 99% of the performance, but it'll take 5 seconds. We'd, of course, prefer the latter. Mm-hmm. And together, this creates an experience that is potentially more unified. We'll switch between models, and we try to give you performance that is better overall than any single model.
Makes sense. So recently, we produced a blog about Max. It's on our website right now at arena.ai/blog, I believe. And we're going to walk through a little bit of the contents of that blog and the lowdown on what Max does and the research insights we got from producing Max. So I'll go ahead and pull up the blog. So we kind of already covered the essentials of Max and how it works, but what we found while researching and producing Max is that Max is like extremely good at producing top results on our arena leaderboard. So at the time of a release, it topped the overall score, but not only that, basically every single important category on our leaderboard ended up being topped by Max at that time, with ELOs usually, or arena scores usually around above 1,500. Anything else to add about that?
Yeah, I think this is worth noting because often we have a model that's number one on overall, but it's not necessarily number one in every single category. That's actually a lot harder, right? So that means there's literally no weakness on your model. And often there's models that are almost good at everything, and then there's one category where they struggle a little bit. So Max doesn't have that, right? Because it switches between models. So if any singular model is weak in any category, we'll just not use that model in general on those types of prompts, right? And I think that's why you see such kind of uniform high performance with this model. And I think that's what makes it interesting. I think we should note that not every router out there is aiming for what I would call better performance than all models it routes over, right? A common strategy for routers is to kind of optimize just latency, where you have a strong model and a weak model, or a couple strong models, a couple weak models, and your goal here is just to kind of interpolate between this in a reasonable way. And you don't actually expect to extract performance that is higher than anybody in your singular routing distribution, right? So this would be like if our router never performed better than the best model within its routing distribution. Let's say today that's Cloud Opus. Can we achieve higher performance than Cloud Opus in aggregate, right? And to me, that's what makes Max, and why we call it Max, right, interesting. It's doing something a little bit more complicated than just interpolating between a strong and a weak model to give you some like smooth performance profile.
Yeah. Is it kind of like we're instead interpolating between like different axes of strength then? Like we're not just like going between weak and strong, we're going between these different kind of types of strength. Strength in code versus strength in writing versus strength in math. We kind of do interpolate between those. We select the best model for each case, and if it's a mixture, we ideally select something that's good at both.
Yeah. I think it's really about like flexibility, right? So if I'm, for example, a lab that produces a model, I might produce a small, medium, and large. That's a very common pattern, right? And if I wanted to route for my users, I can only route between small, medium, and large of my own model, right? I can't use someone else's model. And so that means, in general, right, the design pattern of these companies is probably something like, I'm going to train a big model and distill it down, or use some other method. But the reality is these three, small, medium, large from this mythical lab I'm talking about are highly correlated, right? Where the big model is strong is also kind of where that little model will be strong comparatively for its size, right?
Which is, I'm actually a bit curious personally about this. So as I understand it, a lot of these labs have like specific expert models in different domains that they're trying to combine into one big model. In a sense, I assume that their methods are not wholly dissimilar. So, but we noticed like this kind of like extremely spiky distribution in practice, right? Where like every single model from a different provider is different, good at different things. Claude's very known for coding. I think you told me once that GPT 5.2 High is really good at math. Like we see these like spiky strengths, but if all these model providers are independently trying to optimize for the same kinds of goals at some points, like math and coding, why did we see that in practice, in reality, in the wide world of LLMs, it's so spiky?
I think that's a good question. There's probably many reasons for this, right? Immediately to me, one of them is just data diff. Right?
Yeah.
So it's like, kind of going back to my point of like small, medium, large from one lab, will have similar profiles despite being different models. Whereas if I bring in a new model from someone else, that'll have a different profile. Why is that? Well, fundamentally, a lab only owns the data that it owns, and this other lab owns another set of data that it owns, and those overlap somewhat, and they're also a little different, right? And I think that's what's happening here. Anthropic very clearly has very, very good coding data, right? And OpenAI 2, the codex is very good, right? And another lab might have access to like really, really excellent math data, however they found it or whatever methods they used, right? And so individually, their model has strong coverage, is the way I'd put it, right? It's about coverage over these data domains. And when you put them together via something like Max, then we end up kind of overlapping those data distributions to have much, much higher coverage. So you could think of Max in a way as a model that has consumed pre-training from every single lab. Right? That's a little overstatement.
Sounds very powerful.
Right. It sounds really powerful, and I don't want to overstep, right? But that's kind of what it is. The coverage, like quote unquote coverage of Max, right, is models that have seen this. We talk about someone might have, 20 trillion tokens of pre-training. I mean, we have that.
But this isn't only in pre-training, right? Also the post-training.
Yeah, this is also post-training. So
like Claude probably has really good post-training data for the coding part.
Yeah, I mean, they have access to, for example, Claude code data. So then they can farm that and make a model that's super fast improving in that area, right? Whereas, other models have different strengths. And I think Max is in a unique position to combine that. That's not exactly something that anyone else can do unless you're in kind of a neutral middle position, right?
Sure. Yeah. So the optimistic view is that we are like combining all the pre-training and post-training.
Yeah. The optimistic view is we've made a super god model that takes everything in the world and slaps it together for optimal performance. Of course, that's not fully reality. We're limited, right? So Max isn't a huge model, right? Its job is in some ways relatively simple. It's like take a prompt and choose a model. But it also is trained mainly on Arena, right? And so Arena has high coverage. It has, 5 million plus conversations. And so Max is trained on that. But of course, if we're shifting to a whole different distribution that's really far from Arena, then Max is probably less equipped to deal with that. Of course, we'd love to change that. I think we can.
Yeah. And we'll probably talk a little bit more about that later. All right, so that's a little bit about like, Max's overall really high performance on Arena and why we think it's really like a powerful tool for the average user who wants to do many different things with LLMs. We also talked a little bit about, or we wrote a little bit about like how Max routes. This is probably not something that we can talk about super, super deeply, but I think it's just interesting to note like that at the time of our release, Max really, really liked, it was a Gemini 3 Pro. This was before the Opus 4.6 launch, but at that time, Gemini 3 Pro was quite dominant on leaderboards, and so for the overall routing, Max ended up going there a lot. You can look at the specific pie graph on the blog, but I think that's just of note that sometimes a single model kind of become Max's preferred model, but it's still regardless that even at that dominant stage, like Gemini 3 Pro, look at the number here, made up 38%, right? So Gemini 3 Pro was like super, super top of our leaderboard at this point, but Max still found all those gaps to kind of cover, right? The rest of that 60% was just other models that was really taking advantage of.
I think what's interesting as well is that was unconstrained with latency, right? That we'd be getting this 38% Gemini. We got more interesting results when we started constraining for latency, right? Because Gemini 3 Pro was pretty slow. I think our measured TTFT was in the 10 to 20 second range or something like this, just because it's like a giant thinking model, right? And it's not optimized for speed. And we were able to constrain the latency, and other models started to pull up more, right?
Yeah.
So we could think Claude increased, like Sonnet was increasing. I think some Grok increasing, and some Gemini Flash to increase, right, to cover this gap. And interestingly, by these models are all individually lower than Gemini 3 Pro, right? But when you kind of put them together, you can achieve what Gemini 3 Pro can with much less latency.
Yeah, in some sense, like I think when we were doing these non-latency constrained things, we were looking at, well, this goes against what I said earlier about the categories, but we were in some sense looking at a single axis of model strength on our leaderboards, right? I mean, it's not a single axis because there are different categories and different strengths, but in that sense, we only cared about the strength of the model. When we include the separate axes of like how fast the model is, the routing distribution becomes increasingly complex and pretty interesting.
I think we can talk a little bit about, what are all the things we actually can account for, right? Because I think Max as a framework is quite flexible, right? So right now we're including latency because we want to give users an optimized experience. Nobody wants to wait 30 seconds for an answer to like a simple question, right? And by the way, Max is designed to not give you a bad answer. So if you ask for really hard, like a math Olympiad question, it will not hesitate to give you a really long thinking answer, right? Because, in some way, a bad answer is useless, and so I have to just ask it again, right? So if I have to ask it infinite times because it's wrong.
If it's going to take 30 seconds to answer, it's going to take 30 seconds to answer.
Yeah, exactly, right? You can't save it. But we can look at other things, right? For example, let's say I had some other notion of, say I wanted to optimize for like factuality is a reasonable thing to say, like, okay, given this prompt, like what's the likelihood this model will produce not factual outcomes, or maybe unsafe outcomes, or anything, right? Anything I can measure, I can actually balance against.
Yeah.
And I think that's what's powerful, right? And I actually we don't have to do that much work to rebalance it.
Yeah.
Right? So if users had an ask for us to balance against something, we could actually do that very quickly.
Yeah. Yeah, Max is essentially just a framework by which we can, like, it accounts for this one axis and model strengths, but we can include many other different ways of measuring models and incorporating it into how it routes. It's pretty interesting. And that brings us into the next figure, which is the categorized routing distribution comparison. I think the only thing I really want to say here is that I think it's really impressive that it does have very different routing distributions across these categories. So you might expect like, oh, maybe, what if it's just routing the Gemini 3 Pro and that's how we got all these good results? Not the case. In fact, when you go to code, for example, at that time, it really, really preferred Opus 4.5 thinking, which definitely makes sense. So I think that it just kind of goes to show like Max is underneath like its surface doing something quite intelligent. It's finding the appropriate model for the appropriate circumstance. You have anything to add here?
Yeah. I mean, it's not being like a marginal behavior, right? Would be basically I take the overall leaderboard and I turn those back to like win rates, and I just like kind of like randomly route according to that every single time. That's not what Max is doing. Like not even close, right? It's not even. It's like beyond the granularity of a category too. So even if you took the coding leaderboard and you said like this is now my routing distribution, it's doing something more complex.
Right. These bars aren't even kind of encapsulating the complexity that Max is kind of getting at.
Yeah, and Max is per prompt, right? And so we're able to produce choices on a per prompt basis. Which yields, it's why we can yield these gains, right? So if we were exactly matching marginal, then we wouldn't be able to achieve higher performance than any single model in a category. That's correct, right? For example, if we just follow the category leaderboard, then let's say at a given time, we receive a prompt. And we receive the category that prompt is. And then we just pick the best model in that category.
It would just match the category.
It would just match the category leader, right? We're doing better than that, right? Because we are number one in every category, that implies that we've done something at a more granular scale than even our category leaderboards, which are reasonably granular.
I think so,
right? They in themselves, like, expert versus math versus code, these are all like quite different, or creative writing, right? Code to creative writing, these are very, very different, right?
In fact, I think these categories are kind of like how humans would think about like the kind of ways in which LLMs can differ in strength, right? Like these are what humans care about in their own concepts, but Max kind of even goes below that, right? It's going to find things that maybe we couldn't even perceive.
Yeah, I think we should go into that a little bit. So, when we look at the world of categories on Arena, we look at the static benchmarks out there. People in general are very conditioned to think in strengths and weaknesses in terms of things that are interpretable to us.
Yeah.
Right. So, coding versus creative writing, right? Let's say like math competition math versus instruction following, right? And we're like, oh, this model's good at instruction following. This model's good at math. But in reality, where models are strong and weak might be much more nuanced than that, right? So let's say I have a math query, and the user says, solve this IMO problem. That's one axis. And on the other hand, someone says, here's an IMO problem. Here's a solution. Critique me and teach me why I was wrong.
Yeah.
Those are both difficult math queries, but they might have very different results on which model is better at it, right? So a model that's crazy RLVR to be a god mode at IMO math might not actually be good at explaining to me why my answer is wrong and helping me learn.
Yeah.
Right? Those are very different tasks.
Yeah.
But those both fall into the math category on Arena.
Yeah.
Right? And so kind of if you were to assume that any math query, the math model is best, you'd be wrong, because these performances are more nuanced and in ways that we might not even be able to perceive. It could literally be when asked to output with this formatting, that's like this other model's better, right? Would you ever be able to know that? Definitely not, right? And that could just be because this provider used that format in their RL post-training. Like they preferred boxed and this other person preferred XML tags with answer, right? And when you ask for the XML tags, it locks into that RL distribution that model was trained with, therefore it's better. Identical question, just output format diff, right? And you will never know this, right? Like you can never use a model 10 times and get a vibe of this strength and weakness. This is something that only a system that is trained on millions and millions of data points can begin to infer automatically.
Yeah. So, in short, Max is quite powerful. I think it's reliably better than the average individual human router. If you were to imagine yourself acting as a router, I know 5.2 is good at math. Oh, I know Gemini 3 Pro is as good as that. Claude is good at that. And you're acting as a human router. Max can kind of get into the weeds a lot better than probably you can, just based on the fact that you're not gonna try to figure out all these individual nuances. It's not really worth your time. But Max has all the time in the world, I guess. It kind of just figures it just figures it out. Yeah.
I think we had this discussion a while ago. It's am I a better router than Max, right? Because I know LLMs, I've used lots of them. I feel, am I a better router than Max? And honestly, these days, I don't think I am.
Yeah.
Because a lot of times, I use Max, and it doesn't go where I thought it would go, but the answer is good, and the answer is quick. And so I'm like, oh, well, what do you know? It actually is better than you would expect. I mean, for example, I think one time we were measuring Max with a larger set of models, and a common thing we do is test kind of meme prompts, right?
Okay, yeah.
And it was the how many R's in strawberry, and one time Max said Mistral 8 times 7 be Mixtral, right? Which was a model from a bajillion years ago, and I was like, what? That's wrong.
Yeah.
And then I queried it, and it got it right. And I was like, that's interesting, right?
Respect
it
Max.
knows. It knows, right? And it knows even, there's no universe where I would have been oh yeah, let's use Mixtral from 10 years ago. Okay, not 10 years ago, but from in LLM land 10 years ago, right? To answer this query that's supposed to be oh, the frontier models can get it. Well, guess what? Some models have gotten that for a long time.
Yeah.
Right? And I think those kind of small insights are always very interesting.
Yeah, for sure.
Right.
All right. I think we can move on to the next graph.
I have to test it on that car wash question.
Oh my dude, that car wash question is kind of I don't think it's that high signal, but it's just funny. It's just
It's funny. It's funny. It's definitely not a I wouldn't choose models based off of who can answer that. That's
some people will though. Some people are intelligence as if you could tell that you need to bring the car to the car wash. This is
it's The car wash is 50 meters away. Should I walk or drive? And the point is it's supposed to say drive because you have to drive your car there to wash your car, right? But of course, some LLMs are like, it's only 50 meters, you can walk.
Well, the added nuance is like, it's like I'm out of, or something like I'm out of shape and I want to like exercise or something like that. So it's like, you could push it a little bit. So it's like, come on, you gotta walk, right? It's that close, you gotta walk. And LLM's like, yeah, man, walk. But some LLMs will be able to find out that you need to bring the car to the car wash.
Yeah, it is an interesting puzzle. I don't remember if Max got it right or not, but
I don't remember either.
Eventually it will because it'll get into our data.
If it's in distribution, it'll get it right.
Someone has asked that on Arena at this point and voted, so...
we just gotta wait for more people. We'll ask for more, we'll retrain Max, and then we'll see if it figures that out. I think I could just group these like next few figures all together, these next two. Just talk about like the latency aware stuff. Like you mentioned before, like, when we do latency aware, like everything is so much more interesting because the routing distribution becomes a lot more even, and a quick shout out to us, like it also tops the leaderboard. Like our latency aware version, which was the initial version we released on Max, was also able to top the leaderboard at that point. Of course, leaderboard has changed since then, but at that point it was a top. But I think more interestingly than that is definitely the fact that one, it's fast, and two, that it routes a lot of different places. Like,
yeah, I think we actually purposely tuned the routing to be higher entropy.
Yeah.
So like you can think of at any extreme point. So like I give you infinite latency budget, or I give you zero latency budget. There might be like this kind of local optimum where one model dominates.
Yeah.
And in between, you can see, we made these plots, right, of like, as I vary the latency, how does the marginal routing distribution change, right? And you can see these like kind of plots as different models crisscross with their latency. This model, let's say the top model that's presumably slow will grow over time as we allow for more budget. Whereas, let's say between Gemini 3 Pro, which was top at the time, and Gemini 3 Flash, right, which was kind of secondary, but you could assume that model's like kind of captures a lot of what Pro can do already while being faster. Right, and so what you'll see is Flash might be really dominant at the beginning, and as you increase the budget, it'll crisscross with Gemini 3 Pro, because Gemini 3 Pro kind of dominates Flash because it is the bigger version of it, and there's kind of like a point in this distribution that feels nice because you get this like very even routing distribution, and I think from our perspective when testing Max, it was kind of most satisfying to use at these distributions where it seems to be eager to have like a very diverse routing distribution.
Yeah, at some points we had to test the user ways, but I think that the takeaway is kind of that this trade-off between latency and performance is something that we actually have full control over, essentially. And we of course launched one version right now in Max, but later plots will kind of show that we actually had several different versions we deployed in battle mode with varying trade-offs on latency, and we kind of got different results for all of those, which is really interesting to see.
I think also, in the long run, I'd love to give the control of latency to the user.
Yeah.
Right, because I myself feel sometimes I'm like, I really can't have, I really need like the best of the best. I don't care how long I wait for this question, and I'll just like crank it all the way up, right? Yeah. And sometimes I'm just like vibe chatting. Just give me like the fastest thing possible. I don't really care, right? And so I think giving that control to the user in the longer run, right? We're going to do it now because it's complicated and it takes time, but I think that's probably roadmap. I think we should do it personally. Right?
Me too. But we'll see. But this is definitely something that's like on our radar for sure. Like just giving users more control over what Max exactly they're getting. You have one right now. There may be more in the future. We'll have to see. Also, just a clarification for whatever viewers out there. That plot he was talking about with the crossing lines, unfortunately, it's not on the blog. it's an internal thing. So it's an internal thing. Maybe in the future. Anyways. This is what I was kind of just alluding to. We can also just cover both these graphs together, but I think this was kind of excited our internal team quite a lot, which is that, like I mentioned, we released like six or three, or some amount of variants of Max onto our leaderboard a long time ago. But these were varying trade-offs of latency-aware Max. They had like some of them were more fast, some of them were more, in theory, strong, and we released all of them onto the leaderboard, or the battle mode to see how they perform on the leaderboard. And what's kind of surprised us is that if you draw the Pareto frontier of latency numbers versus performance, most of them ended up lying on that frontier, which is pretty exciting to us. If you have anything else to add about that.
No, I think nothing too much else. I think it was somewhat expected for me because,
really?
you know, I mean, it just has like more flexibility than any given model, right?
Yeah.
And so, you know, when we trained it on Arena, it should be able to do this procedure, right? It should be able to optimally trade off latency. Nonetheless, it's still impressive to me. I think it's quite nice. And it shows that like there's a lot of performance to be gained from mixing and matching these models. Kind of like earlier we kind of touched on that idea of like mixing the pre-training, you know, as a very high level way to think about it.
Yeah.
Mixing the data coverage, right?
Yeah.
These different models really do have different strength profiles.
Yeah.
And I suspect that this will continue to be the case for some time. I don't think we're in the case where any single lab will just run away with like performance and be like 10x better than everyone else in every way, right? And so in the world where we have, you know, more than one dominant lab that's producing high quality models, making different models from different labs, kind of combining those together will always give you this edge, right?
Yeah.
And that's what we're seeing here.
Yeah, actually, I want to add one thing is that, which is that what was surprising to me, I mean, the Pareto thing was originally surprising to me, but what was additionally surprising to me was that these variants were launched, like November last year or something like that. And the plots we produced for the blog were recent plots. Like at the time of the blog, basically, we reproduced these plots. So several new models had come out since then, but these models that we released in November kind of remained on the Pareto frontier. My theory for this is just kind of like, I think as we kind of saw these new models rolling in, we saw a lot of like new points in the top right, which is like slow models that are really good. But this like intermediate area where like it's good but fast, I think is a kind of undercovered area, which is why like our models could continue to kind of dominate that kind of underexplored area of the graph, I think. I mean, there's like Gemini 3 Flash and whatnot that came out, but those are even those are like generally slower than Max is, even like our slowest Max variant. So there's this kind of fast area of this distribution is not particularly covered well. I think that's a gap that kind of Max is definitely taking a strong advantage of.
Yeah, I agree. I feel like when I use other models, it tends to fall into like so fast, but it's like kind of just garbage.
Yeah.
And like I can't trust anything that comes out of it, or like so slow that it takes like, you know, 2 minutes or like a minute to answer my question, and that kind of bothers me. That it just seems like I'm stuck with such a binary choice. I mean, and I think providers are moving away from this. They're kind of like more flexible thinking, right? Yeah. But at the end of the day, it feels like you are using a model that was like, how do I describe this? It's like this model is allowed to think and this model is like not allowed to think. And then you just get like this like huge, I mean, if we just look at our latency, like our average latency graphs for like models on Arena, there's like the non-thinking boys and then the big thinking boys, right? That are like taking a bajillion seconds. And like there's just like this swath of like nothing in between, right? That is, I mean, this is why these plots are log plots, because you would see this giant gap, right? There's like this giant, like 2 order of magnitude gap in between them, or 1 order of magnitude gap. And that's precisely thinking on thinking. But that like middle gap is actually a really nice place to be, right? Because that's where you kind of can get the best of both worlds. And I personally appreciate that Max kind of like hits that mark. Right?
Yeah. Totally. So that's our guess for why November 2025 variants of Max can still be on the Pareto frontier in, what was it, February 2026.
Also, those models are still very good.
Yeah,
right?
they're very strong.
I mean, Gemini 3 Pro
is already in there.
It's high, like Claude Sonnet 5. And you could think like, I mean, you look at the graph, like, why is Claude Sonnet 4.6, for example, better than Claude Sonnet 4.5? There's huge gains, like if you look at Arena, there's huge gains in a lot of the categories that are not coding. And in coding, there's gains, but they're not like giant gains, right? And so we were, for example, already using Claude 4.5 on coding because it's strong there. And when we add Claude 4.6 to the routing distribution, for example, we're going to we're going to use that model in other places more often, right? But that if Claude 4.6 didn't exist, there was a model right behind it. You know, that was like 1 or 2 ELO points below that, you know, was approximately good enough. And so when you look at like, what difference is this new model making with respect to what Max already had, right? Then it's not as big of a difference than you would expect, right? Yeah. Does that make sense?
Yeah.
So I guess the summary is, from a singular model point of view, a new release might be like way better than the other. But from Max's point of view, it might only be a little bit better because we've already kind of used its strength optimally and used its use some other model in place of where it's a little bit weak, which is approximately as strong as what that new model is.
So you're talking a little bit about how, like, for example, use this example of Opus 4.6 and how Opus 4.5 and 4.6 might have pretty similar coding abilities, but what made 4.6 kind of so dominant in our leaderboard is that it kind of grew in all the other areas where it was lacking. It became more of a generalist, right? It was still really good at coding, but it's increasingly better at other things as well. The whole kind of theory behind Max is that we're taking advantage of the fact that each model is kind of good at their own thing. As these generalist models begin popping up, what is the value of Max? Why is Max still providing an advantage to our user over some generalist model?
Yeah, I think there's maybe a couple ways. So first off, kind of like we said, the performance profile is a lot more granular than the categories.
Yeah.
So while Opus 4.6, for example, is very dominant in all parts of our leaderboard, it's not necessarily dominant if I were to somehow break this into even more granular leaderboards, like, take coding, split it into explaining code and then writing code. Okay, take those and break it into Python, C, C++, right? And so as I break them down, or in any other way to categorize them, the performance profile will shift, right? And then Max itself can leverage those, right? Now, and I think it has happened before that we've had a model be very dominant across the board, right? Like, I think Gemini 3 Pro is kind of like this, and we still found, right? I mean, the routing distribution was like, 30, 38, 40% when we had no latency constraint towards Gemini 3 Pro. And so it was clearly still finding kind of like pockets for optimization. And lastly, I guess your argument would be, are those pockets going to be filled, right? So Opus dominates Pareto Frontier today. Will the next version dominate even harder in every single prompt level, right? It's just like simply the best model. Yeah, that's possible. And in the case that there's no per prompt variation in model quality, then Max can't provide anything today, right? Other than good latency routing, right? But I think it's not likely, we'll have bigger problems if one lab is able to uniformly on every situation, every task ever dominate every other lab. And, that also situation probably wouldn't last for long. I think, for example, I'm sure, right now Opus is dominant on Arena. I'm sure another model will very quickly take its place, or in any single category take its place.
I agree with that.
So I'm not extremely worried about that. Because at the end of the day, usage, the LLM is the answer everything engine, right? It's the do anything machine. Yeah. And so you're going to tell me that there's going to be one do anything machine that does everything better than every other do anything machine, like in every situation ever. I think just based off the fact that these models are trained on distributions, their generalization is decent but not amazing, right? And so they cannot necessarily dominate more than too much farther than what, let's say they've trained on this. Can they dominate on this? Maybe. Can they dominate on that? Probably not, right? Just like by those kind of like axioms, we can be more assured that situation is less likely to arise.
That's true. I agree with that. And I know you kind of did slightly brush over this, but I think that latency control is also a big reason. If you look at our just routing distribution for our new latency controlled maps with 4.6 Opus, it's not just Opus 4.6. It's a lot of other models as well. Many of them Anthropic models, but they're different variants.
Yeah, it's actually interesting how much we use variants, right? How much we use still 4.5, because 4.5 has its own unique strengths that 4.6 might have maybe they're lost in the conversion as they were making it better at, say, they're maxing out all the creative writing and all the other categories, maybe they actually lost a bit in some of the coding categories just as a sacrifice. Generally it looks like this, right?
Yeah, and like I said, like we've said before, it's not just latency, right? There's all these different signals we can put into how Max routes. I'm almost certain each one of these signals will produce a very interesting routing distribution that does not get kind of dominated by one generalist, right? These signals are all very interesting.
Yeah, I think like the world of LLM training in general is very, it feels like there's a world of these like trade-offs, right? Where we're like, we want to make the model, better at instruction following, and as a result, we concede slightly on some other metric.
It's like the GPT 5.2 thing, how like they're talking about how they bungled creative writing on that or something like that.
Yeah, I think there's some. Yeah, they're like one of the models. Yeah, it's like not as creative, or maybe it's like we made it really really god tier at writing code and never writes wrong code, but the code is unreadable. Right. So there's like always these trade-offs being made because you can't kind of capture everything. They're getting better and better at capturing everything, right? And I can kind of think of like maybe a rough counterexample where I can always overfit the benchmark, right? So I could always create a model that's good at one singular benchmark, right? And that beats every model in that one benchmark. That's not super hard to do. And so what makes training hard is that you have to like balance these trade-offs.
You're climbing several different hills.
Right, you have to climb all these hills all at the same time, and sometimes these hills are slightly anti-correlated potentially. Right? Like maybe creative writing in some way is slightly anti-correlated with factuality. Right? Because creative writing is about, making stuff up that's like interesting, and factuality is about the complete opposite, right? Like sticking to your facts and being really concise and correct. And so because of that, that limits how they climb, and I think that also limits like each lab has their own perspective on how to balance these. And that ties into like why we see performance move in the way it does, right? And why systems like Max, I think, are reasonable even in a longer run.
So despite what the Twitter influencers say, there's no single God lab. Like everyone's kind of still trying to figure it out, no matter what whoever on Twitter is like.
I would just say like the mandate changes on a weekly basis. Because the mandate changes on a weekly basis, it's okay. Now, if it doesn't change on a weekly basis, you might be in trouble. But the trouble will be bigger than just I don't think I'll be worrying about Max if one model takes the mandate forever.
The mandate of heaven.
The mandate of heaven for AGI.
Yeah. All right. So I think the last thing we probably should cover on the vlog is our appendix. We talk a little bit about Max's benchmarking performance. If I was to give a summary, it's that it's like about on par but does not exceed most of the frontier models at that time on those benchmarks, which I think is still pretty reasonable, given that it's, like we mentioned before, it's primarily focused on our human preference data from Arena, which may or may not include significant portions of this benchmark. I don't think it includes this benchmark data really. So it's still able to kind of extract relatively top tier performance, given that it was not optimized for this at all. Do we want to talk a little bit about what we think this means? And we also have some additional graphs mentioning the latency trade-offs. So as we mentioned, we can do kind of control the trade-off between latency and performance, and we can do the same thing on benchmarks. So we have these plots where we show all these different models and their latency versus their performance on, let's say, HLE, and then also how Max does as a line, right? Because we can create all these different trade-offs. Do you have anything to kind of add about this benchmark experiment?
I want to give my perspective on how I interpret these results.
Yeah.
Because I think when you first glance, you're like, oh, this is not interesting.
Yeah.
Right? The model does approximately as good as just, one model.
Yeah.
Which is true. But I want to caveat that with a couple points.
Yeah.
One is, from the perspective of Max, we shouldn't think about it like Max knows that we're running HLE, and therefore it should pick the best model in HLE. It doesn't know that it's HLE. In Max's perspective, you've just given it some random prompt and it's decided which model to go.
Yeah.
So the fact that it picks the top model for HLE, even if it's not a super interesting routing distribution, it's not producing kind of like Arena, we see this kind of elevation where we're better than any single model. We're not seeing that on these benchmarks. It's impressive in itself, right? That it's picking a model that is really, really good.
Yeah.
because it doesn't know which model is really good. It doesn't have access to web search where it can search up HLE scores are A, B, and C, therefore I should pick model 1, right?
Yeah.
It's a bit like let's say a new benchmark came out. That's some static benchmark. We believe it's good. Some like HLE2, right? And I don't know the scoring of HLE2. I just see the prompts, right? I don't know any of the scores of any model on HLE2 yet, But you just give me a bunch of prompts for HLE2 and you say, try to top HLE2 right now. Mm-hmm. Max would probably be able to top or like get close to top of HLE2, even though it doesn't know the scoring function. It doesn't know what the outputs of the models look like, right? It just sees the prompts and it decides, hey, let's choose this model. And I think that's impressive, right? And I think that's a little slept on. People don't realize that, this is in itself a non-trivial prediction problem. And I think, why don't you talk about kind of the latency aspect of this, because I think that's interesting as well.
Yeah, so these plots that we generated for you guys originally actually look quite strange. This is what you're referring to, correct? Yeah, it looked quite strange. We plotted them and they just basically, they were like, Max was like not really like a line. It just made no sense. It was like jagged, whatever. It was squiggling around everywhere. And what we noticed is that, well, right now our latency control is based on these like aggregate numbers, right? So like how fast is X model in general, like mean or median, like whatever, like on all arena data. This benchmark is like a quite different distribution of prompts compared to our arena data. I mean, it just is, right? It's like extremely different. So these latency estimates no longer become quite accurate. Mostly what we see is like these thinking models end up thinking a lot longer. There are tougher problems. To some extent, they're probably trying to do really well in the benchmark, so they just, they kind of lock in a little bit. They're like, they lock in. And so when we replace these kind of numbers that we got from aggregating all arena data with just aggregate on the specific set of HLE or GPQA or whatever, we found these like really beautiful lines essentially that I kind of interpolated between fast and strong models and like slower and strong models on these benchmarks. Like if you look at the HLE one, this is like kind of like gold standard one. It's basically directly goes from, let me double check. It's Gemini 3 Flash thinking minimal and Gemini 3 Pro. Like it's technically like per frontier, right? It is technically.
It's doing something very, very reasonable.
Yeah, it does something very reasonable. So I mean, this kind of shows to us on our research side that like Max requires to have latency estimates when it's doing this kind of balancing that are kind of appropriate. If you're going to give it some crazy stuff, something that's very out of its distribution, its trend distribution, it might struggle. And kind of the importance of having good latency estimates in making Max perform well.
I think we can do better here, right? I think we can produce latency predictions ourselves.
Yeah.
Right. So instead of using the expected latency overall, we can use the expected latency given the task at hand or something like this.
Yeah.
And I think that's all within reason. And that would actually fix this.
Right. Yeah. This benchmarking thing is kind of just one example of a wider problem, which is that latency is prompt dependent. It's very prompt dependent. It's prompt and model dependent, right? Like if you feed a certain model hello and you feed a certain model like an IMO problem, it's going to take varying amounts of time to complete that. Maybe IMO is a bad example because maybe they've kind of tuned for that. But like even if you just give like a tough math problem it's never been trained on, it might still think a lot longer. So this is a very like not just benchmarks overall. Like every prompt kind of incurs a different latency from these models, and for us, a top priority is kind of being able to get better estimates of these latencies and feed those numbers into Max so Max can make a more appropriate decision. We're kind of giving Max like the best information available to make its decision, right? If we give it flawed information, it's going to make a flawed decision. We got to give it good information, so that's something we're actively trying to figure out.
Yeah. And I think one thing that's hard about these benchmarks is, say, routing on Arena to produce a higher than any single model Arena score is actually more feasible because Arena is a benchmark with millions of prompts, right?
Yeah.
And so you're really, the coverage of that benchmark is just massive, right? There's creative writing, there's coding, there's all these like microcosms of interesting things people are asking about. And we can leverage that because this inherently, to be good, the model needs to be good at such a wide array of tasks, which is generally where we can find one model being better than the other on a given kind of like pocket, right? This is not necessarily quite as true with the static benchmarks. You think about Amy, 2025, right? That is testing this like sliver, right? Again, I'm calling this like the answer anything machine. You're asking Amy 2025, if I believe, is 15 questions, right?
30, I think it's like 2 halves.
2 halves, 30 questions.
Something like that.
So you're asking 30 questions to test the answer everything machine, right? And so that kind of coverage is very, very low, and it's hard to expect something like Max to do a lot of like fancy jumping around, because fundamentally the performance on this sliver is not that diverse between models, right? And the same follows for a lot of these benchmarks, which is why, for example, having high average across all benchmarks is pretty good, because that means you're jumping, let's say one model's better at the math benchmarks, the other one's better at, you know, a factuality benchmark or something, and you want to like bounce between them and show high performance. But within a single benchmark is very, very hard, right? And you look at, for example, you look at Amy 2025, and you see like, you open it up and you see like which questions are wrong, or like you look at IMO, which questions are wrong. When you look at one wrong, generally all the other models get it wrong as well. Let's say a famous one is, I think, IMO 2025 question 6. I've never seen a model get that one right.
Me neither.
Because it's like some heinous geometry question of like tiling, right? Where the model just says like, no idea. And it gets it wrong every time. And so all the models get it wrong. So if all the models get it wrong, we can't do anything about that.
If the performances are not that different, then what do we do about routing?
And what happens on these static benchmarks, generally, models are, you know, they're very small in their measure. Not, some of them are bigger, right? But at the end of the day, they're all kind of like under 10,000 questions, right? It's usually somewhat constrained in topic. And even if the topic that, like, we touched on this earlier, right? Topic of like what we believe differentiates model, creative writing, coding, and what really might differentiate, which is like much more granular than we might understand, right? And even though a static benchmark might have seemingly high topic coverage, the actual like skill area coverage might not be as large as you think, right? For example, you just toss them into embedding space, they might actually be really tight, or be like several very tight distributions of you know, like all like the, you know, GPQA biology questions are like this embedding space, you know, like tiny little ball here, and then like, you know, the chemistry ones are a little.
These benchmarks are only diverse to humans. To LLMs,
to humans, you're like, wow, there's like chemistry and biology. Well, like look inside of biology, they're like, you know, maybe they're all very, very correlated. And as a result, right, the models don't kind of have interesting performance profiles. They all fail at once. They all succeed at once, right? Or like one model just dominates, right? Because it's only a few thousand questions at most, and so we can dominate. And I think that's what makes these particularly hard, and somewhat representative of like, you know, what is this benchmark actually measuring? Like how much should we read into this, right? It's really when you put them all together. Right? Also, like I mentioned earlier, any single benchmark can be maxed, right? Just because it's such a small sliver, and so it's really about like putting them all together. Can we, you know, I think our goal, right, for Max moving forward, if we want to be better at these benchmarks, is not necessarily to like try to get like this Oracle God performance where we achieve better than every single model. Rather, across all of them, we should have the most consistent, reliable performance, right? Regardless of if you're asking Amy or Simple Bench or Simple QA or HLE, we should be in the top contenders.
I mean, no one really uses a single benchmark as the end-all truth. They use a host of benchmarks, right? And so that's what we're aiming for, not just a single benchmark. Anyone can dominate a single benchmark. Well, it's more difficult to be able to be consistent on all of them. Cool. I think that more or less covers the blog. This is kind of what we were. This is what we wrote. This is what we worked on. We gave you a little bit more of an in-depth overview with some kind of side comments and discussions. We hope it helped you learn a lot. If you want to try Max, please do so at arena.ai/Max. The blog is on our blog, arena.ai/blog, if you want to take a closer look at the graphs that we mentioned. And ideally in the future, we'll be producing more research about Max, producing more variants of Max, and kind of trying to do as much as possible to push the frontier with Max.
Yeah, I think we'll have updates more for Max moving forward. I think, you know, it won't stop here. We've added Opus. We'll probably add the other models too, and more modalities, search, etc. We want to make it a more unified experience for everyone. So check it out.
Yeah.
And when you vote on Arena, it helps power Max.
Yeah, exciting things coming. Thanks.
Yeah.